Hey guys, welcome to AKV and this is Vishnu. So this illustration, a company is considering two mutually exclusive Project X and Project Y. Project X cost 3 lakh and Project Y 3 lakh 60,000. You are you have been given below the net present value probability distribution of each project. So you have been given the net present value and probability of each product. So we have the project X and project Y. Net estimated income will be 30,000, 60,000, 1,20,000 and 1,50,000 and their respective probability 0.1, 0.4, 0.4 and 0.1. When it for the project Y, it will be net estimate will be 30, 60, 1 lakh 20 and 1 lakh 50 and respective probability 0.2, 0.3, 0.3, 0.2. Going further, compute the expected net present value of the project X and project Y. Compute the risk attached to each project, the standard deviation of each probability distribution. Then the third one, which project do you consider for more risky and why? Compute the profitability index of each project. So then we have the second part of the question, which is part B. Determine the risk adjusted net present value of the following project. So we have given three projects, and first we have given net cash outlay will be 1 lakh, 1 lakh 20,000 and 2 lakh 10,000. Project life will be 5, 5 and 5. Annual cash inflow 30,000, 42,000 and 70,000. Coefficient of variation 0.4, 0.8 and 1.2. Then the companies selects the risk adjusted rate of discount on the basis of the coefficient of variation. So the company is selecting the risk adjusted return on the basis of coefficient of variation, and then they have given a table which contains three columns: coefficient of variation, risk adjusted rate and present value of from 1 to 5 years, the total present value. So from starting, coefficient of variation 0, which is 0.1 and 3.79. Next one 0.4, that is 12%, 3.695. Then 8, 1.2 and 1.6. Then 2, then more than 2. So when it comes to risk adjusted, it will be starting 0.1, 0.12, 0.14, 0.16, 0.18 and 0.22, 0.25. Here the net present value 3.791, 3.605, 3.433, 3.274, 3.127, 2.864 and 2.689. So first we will consider the first part or the A part of the question, for which we will need to compute the net present value, expected net present value, and then risk attached to each project and which project is much risky, and compute the profitability index. For that we have made a column which contains 6 columns for project X. So first we take the net present value, net estimate, which is given the question as 13, 15, 1.2 and 1 lakh 20,000 and 1 lakh 50,000. Then when we multiply it with the probability, we will get the amount as 3,000, 24,000, 48,000 and 15,000. Therefore the total amount will be 90,000, which is computed as average or mean. So when we next column is the expected NPV, which means x minus x dash. So x dash is 90,000 minus x is 30,000, 60,000, 1 lakh 20 and 1 lakh 50. Therefore 30 minus 90,000 will give you negative 60,000, and 30 minus 60 minus 90,000 will give you negative 30,000 and 30,000 and 60,000. Next we need to square these figures, x minus x dash. The 6,000 to 6,000, 30,000 to 30,000, 30,000, 6,000 into 6,000, which gives you these figures. After that, x minus x dash the whole square, then we need to multiply it with probability, which gives you 36 crore each. So the total will be 144 crore. The same way we need to compute it with project Y. So the project Y estimate or the cash inflows are 30, 60, 120 and 1,50,000. When it multiply with probability, we will get 9,000, 1,80,000, 18,000, 36,000 and 30,000. When we take the total, we will get the x dash or mean. When next column is x minus x dash. X is the NPV estimate minus x dash is the average, which is 90,000. We will get negative 6,000, negative 30,000, 30,000 and 60,000. After computing the x minus x dash, we need to multiply it or square such figures. The 60,000 to 60,000, 30,000 to 30,000, etc. So we'll get the amount of x minus x dash the whole square as 360 crore and 90 crore, 90 crore and 360 crore. And after that we need to multiply it with the probability. So 360 crore multiplied by 0.2 will give you 72 crore, and 27 crore, 27 crore and 72 crore respectively. Therefore the total amount will be 198 crore. After that we need to take the root. So the expected net present value of project X and Y will be expected value of project X and Y will be 90,000, which is the mean. Now we will take the standard deviation. So for the computation of standard deviation, we need to take the root of each project, that is this square of the deviation of probability, which is root of 144 crore and 198 crore. Will give you 37,947 and 44,497. Next one, coefficient of variation, standard deviation. So which is the standard deviation divided by mean or expected value will be the coefficient of variation. Therefore 37,949 divided by 90,000 and 44,407 divided by 90,000, 0.4216 and 0.4944. So when we check here, we can understand that project Y is much riskier, which is the coefficient variation is higher. Therefore the project Y is much riskier. Now which is the fourth part of the question, which is the probability index. So the formula of the probability index will be discounted cash inflow divided by discounted cash outflow. Therefore 90,000 is the income plus 3 lakh is the investment, therefore 90,000 plus 3 lakh divided by 3 lakh will give you 1.3, and for project Y it will be 90,000 plus 3 lakh 6,000 divided by 3 lakh 6,000 will give you 1.25. Now the second part of the question, which is a statement showing determination or computation of risk adjusted net present value. For that we can check the question. So here we have given the net outlay or the cash outflow as 1 lakh, 1 lakh 20,000 and 2 lakh 10,000, right? Yes. So here we have written as net outflow as 1 lakh, 1 lakh 20,000 and 2 lakh 10,000. Next we have risk adjusted discount factors 0.4, 0.8 and 1.2. Then risk adjusted discount rate will be 12, 14 and 16. Annual cash inflow will be 30,000, 42,000 and 20,000. So here we have given the risk adjusted discount factor as 0.4 and 0.8 and 1.2. So when we check these figures in the table, which is 0.4, 0.8 and 1.4, we will get the risk adjusted factor as 12, 14 and 16 percentage. So we have written here as 12, 14 and 16 percentage. After that we can easily available from the question that the amount of cash inflow, which is 30,000, 42,000 and 70,000 respectively, from the table in the question, which is 30,000, 42,000, 72,000. After writing those figures, we have the 5 years present value PV factor for these 12 percentage, 14 percentage, 16 percentage, which is given in the second table of the question, which is 3.605, 3.433 and 3.274. So when we multiply those figures, we will get the net present value as 8,150, 74,000, 24,135 and 19,180. Guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe.